Hello dear students, in this video we are going to discuss about volume integral and Gauss Divergence theorem, or you can say Gauss's Divergence theorem. So first let us understand volume integral. Let V be the region in the space bounded by the closed surface S, then the volume integral of a vector point function Fy is given by triple integration of vector field Fy over the volume V dV. Here there are two types of the volume integral. If the vector field Fy is a vector, so in that case, we can say that the component form of the vector point function. It means that F1i plus F2j plus F3k. So this is our vector field Fy. So in that case, we can say that component form of the vector volume integral. But if you are given that the scalar function, so in that case, volume integral will be, that is the scalar form of the volume integral. Now let us see that the next Gauss's divergence theorem. If vector field Fy be a vector point function having continuous partial derivative in the region bounded by closed surface S, then triple integration. This is the divergence of vector field Fy. dV is same as double integration Fy dot n cap ds over the surface S, where n cap is a unit outward normal at any point of the surface S. Also, it is known that if the surface is given as a level surface, so in that case, our unit normal vector will be n cap is equal grade phi divided by its length. Now, let us see that a simple question. Verify Gauss's divergence theorem for the vector field Fy over the upper half of the sphere x square plus y square plus z square equal to a square. So this is the upper half sphere. This is the upper half sphere. That is x square plus y square plus z square equal to a square. So by Gauss's divergence theorem, so this is the statement of Gauss's divergence theorem. Here Fy is given, so we can find this is the divergence of vector field Fy, and that is what phi z that you can find. What you can do, del phi by del f1, this is the f1. So we are doing partial derivative of this function with respect to x, so it will be, that is the 2z. Again, you will get partial derivative with respect to y, so so answer will be only z, and here it will be 2z. So your sum will be 5z. Now, triple integration of divergence of Fy dV over the volume V, that can be written as triple integration 5z, because divergence of vector field Fy is 5z, and dV can be written as dx dy dz, where V is the upper half of the sphere x square plus y square plus z square equal to a square. So to evaluate this triple integration, we are using that the spherical coordinate. We all know that spherical coordinate of sphere is x is equal r sin theta cos phi, y is equal r sin theta sin phi, and z is equal r cos phi. To get the upper half of the sphere, we have to consider the radius that is 0 to a, and theta from 0 to pi by 2, and phi that is 0 to 2 pi, and dv will be dx dy dz equal to r square sin theta dr d theta d phi. Now substituting all these value over here and using that limit, we will obtain that this one. Now this is the limit for phi, this is limit for theta, this is limit for r, and whatever we have, this is a phi term. So phi is outside of this triple integration, and z is equal, that is the r cos theta dx divided dz is equal r square sin theta dr d theta d phi. So whenever we perform that triple integration, so we can notice that constant is that. So there is no any function of phi. So you can write this is the integration for phi, and again you can do the integration for the theta. So in that case, you should keep terms cos theta and sin theta all together, and integration of r of the function r raised integration with respect to r of the function r raised to cube. So it will be r raised to 4 by 4 over 0 to a. Substituting upper limit and lower limit, a raised to 4 divided by 4. Again, you can do that this integration, that is minus cos 2 theta divided by 2 it will be, because in that case you have to take the 2 sin theta into cos theta and again divide by 2 is that. So but this is 1, this is sin 2 theta and 1 by 2 outside of this integration, and theta is equal, that is 0 to pi by 2. So whenever you perform integration, it will be minus cos 2 theta divided by 2 over 0 to pi by 2, and after putting the limit you will get this one. So at the end, after simplifying, you will get 5 by 4 pi e raised to 4. Now given surface is not closed, so we close this surface from below by circular surface S2 in the xy plane. The surface integral S consists of two surfaces. First one upper surface S1, and this is in the xy plane, that is the S2. So our required surface will be double integration over the surface S1 and double integration over the surface S2. To find out the surface integral of our S1, and we can notice that this is the S1 is the Gauss surface of the upper of the sphere. So this is our surface given. This is the level surface also you can say, so you can find the normal vector, and we know that its length is 4x square plus 4y square plus 4z square from this one. Whenever we take the 4 common, so it will be x square plus y square plus z square, and x square plus y square plus z square is nothing but a square. So let us replace over here. So square root of 4 times a square, so it will be only 2a. So 2 will be cancelled out, your answer will be only a. Now let R be the region with the projection of the xy plane, which is the circle. So we have x square plus y square equal to a square. Now ds is equal dx divided by mod of n cap dot k cap, because we are taking projection on xy plane. So k cap is parallel to what, that is the z axis. So dx divided by n cap, that is we have derived, and k cap is also there. After taking the dot product, we will obtain this one. So therefore double integration over the surface S1 f bar dot n cap ds. So we have f bar is we have this one, n cap also we have, and ds is also we have. So a get cancel out, z is also going to be cancelled out. You can notice from here. So you have 2x into x, that is the 2x square, plus y into y, this is a y square, plus 1z into z, that is the z square, dx dy. But since given surface is x square plus y square plus z square is equal to a square, so you can make z square as a subject and you can replace over here. So you will obtain that double integration over r 2x square plus y square plus a square minus x square minus y square. So here y square is going to be cancelled out, 2x square minus x square, so it will be x square and plus a square dx dy. Now to evaluate this double integration, so you have to perform use that parametric equation of the circle. But we know that parametric equation of the circle, that is x is equal r cos theta and y is equal r sin theta. So dx dy will be r dr d theta. So therefore the limits are r is equal, that is a radius circle, so we have limit for r, that is 0 to a, and to get the circle we have to rotate theta, that is 0 from 0 to 2 pi. So after substituting all these the value over this double integration, we will obtain this one. First we do the integration with respect to r, so r square into r, that is r cube, so r raised to 4 divided by 4 cos square theta, plus 1 time a square, so r square divided by 2 into a square over r is equal to 0 to a d theta. So let us put first upper limit, r is equal a, so a raised to 4 divided by 4 cos square theta plus a raised to 4 divided by 2 d theta. Here you can notice that if you supposed to do the integration with respect to theta, you have to use that formula cos square theta is equal 1 plus cos 2 theta divided by 2. Use it over here, and after that you do the integration with respect to theta. So 1 by 8 is there. Integration of 1 with respect to theta, that is a theta, plus integration of cos, that is a sin 2 theta divided by 2, plus 1 by 2 theta over 0 to 2 pi. So whenever we put theta is equal to pi, so we will obtain that 1 divided by 8 2 pi plus theta and plus 2 pi divided by 2. But when we put theta is equal to 0, so answer will be 0. So after simplifying, you will get a raised to 4 times 10 pi divided by 8. So you will get 5 by 4 a raised to 4 divided by, sorry, 5 by 4 a raised to 4 into pi. Now for the surface S2, and surface S2 is nothing but in the xy plane. So we can say that x square plus y square is equal to s square. That is the we can say circle, equation of the circle, with z is equal to 0 is that. So in that case, you can notice that its outward unit normal vector will be in the below direction side. So therefore we have minus k cap. So ds also can be written as dx divided by n cap dot k cap. So here n cap is what, minus k cap and dot k cap. So answer will be minus 1, but mod of minus 1 it will be plus 1. So we have ds is equal to dx dy. So therefore the surface S2, double integration over the surface S2 will be answer that is 0, because of that itself is 0 and k dot k that is going to be 0 and all this part will be what, that is going to be 0. So therefore its answer will be 0. Now we are substituting all these value in equation number 2. So therefore double integration of the surface S equal to double integration of the surface over the surface S1 plus double integration over the surface S2. Surface S1 has the answer 5 by 4 pi a raised to 4 and S2 is the answer that is 0. So you will get the equation number 3. So from the equation number 1 and 3 you can notice that both have the same answer. It means that Gauss's divergence theorem is verified. Let us see the next very simple question. And you have to think that where we can use that as Gauss's divergence theorem. So here it is not specified that we use that Gauss's divergence theorem. So evaluate double integration over the surface S ds bar, but whenever ds is there, we can use that n cap dot ds that we all know, where S is the surface of the sphere in the first octant. We are talking about in first octant. So using that Gauss divergence theorem, so this will be same as, because ds bar is same as n cap ds. So we have according to Gauss's theorem. And now you need to find out divergence, because F1 is given that and Gauss's divergence theorem that we are going to use. So we have to find the divergence of the vector field F1. So you will get the answer 0. So therefore your final answer double integration will be for that is 0. Thank you.